Okay, in this video, I'm going to walk you through putting this demo design into EDA Playground. So first of all, I've given you a template where most of it's already put in because I didn't want to overwhelm you with too much typing to put it all in. Okay, so what we're going to be doing here is we look at this list. We're going to be adding the Add 1 module to the design, the Add 2 module to the design, and then we're going to instantiate Add 1 and Add 2 to the top module, and then we're going to instantiate the Select module. From there, we're going to run a simulation to make sure things are, look like they're going to run correctly, and then we'll be able to export those results to the box folder so that then we can import that into Vivado and target the design for the hardware. Okay, so by this time, you should have created an account for EDA Playground and then use the link from Canvas to open up the playground that I sent you the link from, and then you'll hit this copy button so you can save that to your workspace. You can't save it to your workspace unless you have an account, and you'll need to be able to do that. Okay, so you see here we don't have Add 1 or Add 2. We do have the top, demo top, but we need to instantiate some things. Okay, so how do we get started with this? The thing that we need to do is to wrap our head around the schematics. Okay, a schematic is very important for capturing the design. In the old days, we drew out all of our designs on a piece of paper, and then you would wire it up from the paper. Okay, so I've got this design, and each of these modules are represented by rectangles on the design. So I have an Add 1 module that takes the input X and adds 1 and puts the output on this 4-bit line. The /4 means these are 4-bit vectors. Okay. The other thing to take a look at when you're digesting these diagrams is you want to figure out what are the inputs, what are the outputs, and what are the wires. Okay. In this particular one, I color-coded everything. So the red lines are inputs to the top. Okay, the blue lines are outputs, and they have arrows coming out. Okay, arrows coming in for inputs, arrows coming out. Okay, and then you can infer that this module for Add 1, the lowercase y, is an output because the wire coming out has a direction to it, so y must be an output. Okay. So we're wrapping our head around what are inputs and what are outputs. Within this module, Add 1, X is an input, A on Add 2 is an input, W on 2's complement is an input. We can look at these numbers here and we can say, oh, that must be a 4-bit vector coming in. This is 4 bits for A and 4 bits for W. X, B, and Y are outputs, and we need wires to connect those to the select lines. Okay, so that gives you an idea. You can start wrapping your head around the schematic. So within a module, you can tell what the inputs and outputs are, and then within the top module that we're putting all these things together with, you can tell that the input is X, there's yellow lines that indicate wires, and there's blue lines that indicate outputs. Okay, so let's get started with adding Add 1 and Add 2 to the design. Okay, so the first thing we need to do is we need to create another tab across here. All right, so I hit this plus button, and we're going to do add 1.sv. SV stands for System Verilog, and so we're going to use that file extension. Okay, so we're going to create that file, and that shows up here. All right, so next, I want you to type this in because you're trying to learn Verilog as you go, and you need to know about the syntax. Okay, so Verilog is forgiving in terms of spacing requirements, just like MATLAB. It's not like Python that's very space-oriented. All right, you got to get the spacing right in Python. But what we do here is we just type the word module, and then we need a module name. The module name in this case is Add 1. All right, then it looks like a function call within MATLAB. Okay, but you need to specify what are the inputs and what are the outputs. So if I looked at the add one input, I go back to the schematic, X was the input and Y was the output, and they're both 4 bits. Okay, so what I need to do is put 3 down to 0. So we're learning as we go. That should be a colon. 3 down to 0. That notation specifies that this is a 4-bit input, and I'm using uppercase X. It's important to get the variables typed exactly right because Verilog is case sensitive on variable names. Okay. All right, then I have an output. Again, that's 4 bits, 3 down to 0. And that output, I said to get the case right, but in the diagram, it was lowercase x, right? Let's verify that. Lowercase x, lowercase y. All right, we're going to do just like the diagram. Lowercase x, lowercase y. All right, and then close parentheses with a semicolon. All right, so you end the module definition with a semicolon. You list all the ports inside the brackets. Okay, now a lot of designs start having, a lot of inputs and outputs, and so my preference for style is to just go ahead and hit a return right here, and so I can start seeing the listing of inputs and outputs vertically. Okay, that's my preference because later on we start to see a lot of these things, and it's easier, I think, to look at going down than it is across, and you can make things line up neatly, and that's just how I like to do it. Okay, I think it's a good coding style. Okay, then all modules have an end module, and it's just one word. It's all one word. Okay, so we've got this set up. We've got the module. We got the module name. We open the parentheses, put the input x, comma. All the inputs and outputs are separated by commas, just like a function call, and then everything ends with a close parenthesis, semicolon. All right. So from there, we are doing very simple modules, although there's a lot that's going to happen under the hood whenever you put something like a plus sign. Okay, but we don't need to worry about that right now. We're just going to do an assignment statement. So right now, that's the main thing you need to know. We're going to add in different ways of specifying designs within Verilog, but for now, whenever we want something to happen within a module, we're going to use an assign statement. We'll get away from that quickly, but that's what we're going to do for this particular lab. Assign and instantiations are the main things that we're going to do. Okay, so we're going to assign the output y is equal to x plus 1, and then you terminate the line with a semicolon. All right, so that's the add one module. All right, and now, I've got this in a separate file. It's nice to keep things in separate files to help keep your whole workspace organized. Okay, so I want that to be incorporated in the design, so I have to include it. All right, so the way EDAPlayground works is it looks for this design tab. You can't change the name on that, that's fixed. It looks for this design tab, and from here I like to farm this out to have all the different modules within the design to show up in tabs where they're different file names, but then I have to include them back into the EDAPlayground. Okay, so to make that happen, you use an open quote. All right, so that's the upper corner of the keypad on my Mac. That's right underneath the tilde key. All right, so it's an unusual key. We don't use that very often. But then you type the word include, and then you put in double quotes. All right, so that's right next to the return button on my keypad or keyboard. And then you add the name of the module, add1.sv. Okay, and we're going to also add to, so let's go ahead and put this into the include, and then I want you to pause the video and try to do the add to module just like you did the add one, and try to, get everything on your own without going back and looking at every step. And if you get stuck, we'll go through it. So pause the video and we'll come through it here in a second. Okay, so next we're going to add to. So we'll put the add2.sv, create that file. Again, it's a module. So you type the word module, the module name, and then we're going to have the list of inputs. All right, so how do I get the list of inputs and outputs? I look at add2, all right, and I see add2 is the module name. I have A and B. These are 4 bits, all right? So we can make that, all right? So this would be, because it's 4 bits, you specify the bit length first in Verilog, 3 down to 0 of A, and then output 3 down to 0 of B, and that's it for inputs and outputs. You close that with a close bracket, semicolon. I tend to put this on the next line down just for style reasons. Okay, and then every module has an end module. It's easy to forget those, and it's confusing to look for them, so try to remember to put those in. All right, so from there, remember how we made the action happen within the module. Right now we're restricting ourselves to assignment statements. Okay, so we're going to assign the output B to be A plus 2. All right, so there's that module completely added in. All right, so we've added the 2 module. Let's go back to our list. We've done this one, and we've done this one. All right, now we want to instantiate add1 and add2 to the top module of our design. Okay, so we go to the top module. All right, and you see I have a comment line that's showing for where I want that to be done. All right, so I'm going to instantiate the add1 module. So I just type add1. Okay, then I need a label. All right, so going back to the schematic, one thing you could do is you could put the label in here so that whenever you're debugging things later, you'll know what the label is for that particular module. Okay, there are some naming conventions that people use. What I'm going to try to do is, this starts with an A. Add1 starts with an A, so I'm going to make this capital A1. All right. Well, add2 also starts with an A, but you can't have the same label within a module. So I need a different label, so I'm going to call that A2. All right, so using that naming convention, I have something reasonable. There's flexibility with this, and different people do different things. Okay, notice I did the same thing with select. Starts with an S, I put S1, and then 7-segment decoder, that's a module name. Starts with an S, and then it's the second module. So now I have unique labels for every module. Okay, so that's what we're going to do next. We're going to put in that label. So with add1, the label is A1. All right, then I just look at the inputs and the outputs from the schematic. All right, there's just 2 here, so I tend to not go vertically with that when there's just 2, but if there's a lot of inputs and outputs, I'll start putting this vertically down the screen here. All right, so I'm looking at add1, and I know that capital X gets connected to the input lowercase x on add1. Okay, so what I do is I type .x at the lowercase because that's the input for the add1 module. Okay, and I tie that to cap X. Easy enough. All right, and then .y is the output. All right, and so what I'm seeing here, I'd already defined the wires. All right, so normally if you're going to implement this whole thing, you would define the module, inputs and outputs, and then if there's any wires, you need to define those next, and then you can instantiate everything from there. Okay, so I've defined the wires. I'm looking at this schematic and I see that the B wire is connected to lowercase y on the add one module. Okay, so here we go. The B wire, BW is what I call it. I use a subscript, an appending W to help me keep track of what's wires and what's not. All right. Okay, and then that's it. We've instantiated that. It ends with a semicolon. We'll do some spacing here to help things line up. Okay, so we've instantiated that. Now, let's instantiate add two. All right, so pause the video. Try to do that on your own. Okay, look at the schematic. See what the inputs and outputs are and make all the connections. Okay, so hopefully you've done that on your own and you came up with the right answer, but let's go over it just in case. So add two, I look at the schematic, the name of the module is add two, the label was A2. It had an input. Let's go back and look. The input was A and the output was B. All right, so dot A is the input and dot A gets connected to X, following the wire. This is why the schematic's important. X goes to A. All right, so then I would type cap X. And then dot B, the output, goes to the C wire. B is connected to the C wire. All right, so CW. Close the parentheses for instantiating the module. All the parentheses match up. You see, start noticing, the EDA Playground tries to help you keep track of parentheses by looking at these color codes. All right, so then it ends with a semicolon, and we'll line this all up, and we're starting to look good here. All right, so we've now instantiated add one and add two. All right, so now I need to instantiate the select module. And so we type the module name, select, the module label, S1. We got that from the schematic. Let me verify that. Yeah, S1. And then we start looking at the inputs and the outputs. Okay, so I have dot A as an input, and looking at the schematic, cap A goes to X, B goes to B wire, C goes to C wire, and D goes to D wire. So we're going to take care of these four. All right, and this is what I'm talking about. Sometimes it's useful to start putting things vertically because there's a lot here on this one. Okay, so dot X of X, comma, dot B goes to B wire, dot C goes to C wire, dot D gets connected to D wire, and that's the 4-bit inputs. All right, we also have dot A, all right, and we see that's connected to, we look up, down, left, right, UDLR for the inputs A, B, C, D. All right, so dot A, dot B, dot C, dot D. Let's see if we get those in the right order. Up, down, left, right. Okay. All right, that's the inputs. All right, and then we also have the outputs, but the notation is the same. So I look at this for the outputs on the schematic. I've got Y and GS. Okay, so Y is connected to wire YW. Okay, YW is already defined as a 4-bit wire. Okay, so on the input side, Y, it's YW. And then dot GS is connected to this spawn. And that should be it for that module. All right, so I'm going to move the comment up here. Instantiating the select module. Okay, so that takes care of our list. We were wanting to use the design schematic to instantiate the select module. That's this step. Okay, from here, what we need to do is we need to run this as a simulation to make sure things look like they're connected correctly. Okay, so when I hit run, what should happen is this is going to open up a waveform after we run, and we'll be able to see whether or not everything looks like it's connected right. Okay, so how you can tell is you should start seeing values showing up for LED, SEG, and SW, and the signals are showing here for the button presses. All right, so it looks like everything's working correctly. Don't worry about that part right now. If you see a bunch of red stuff or signal values that aren't defined, there's something wrong, and you'll need to talk to me to try to figure out how to debug that. Okay, so I'm thinking things are pretty good, and we're ready to move to the next part where we're going to export all the files so we can put it into Vivado, because ultimately what we want to do is target this design for our Basis 3 boards. All right, so to make that happen, what we need to do is download the files after the run. Okay, so I click on that button, and this is going to show up in your downloads folder. It's going to be a zip file that has all the files that you need in order to make your design where you can import it into Vivado. So I hit run here, and what you see is the results going to a zip file. All right, so from there, what you can do is you can pull up your file manager, whether that's on a Windows or on a PC. And so I have this sitting here, downloads, and I can see if I open this, I now have all the design files that I can copy and paste. Okay, so I can take that, copy this, and then I've already set up my box folder for the labs. Lab 1, sources, and I already pasted this in, but you could redo this paste. Okay, so at that point, I've got all the sources into a directory, and I'm ready to go with Vivado, which will be the subject of the next video.